Good evening, my dear students. Welcome to channel Guruvartha Kirti. In the last class, we have discussed about the degradation model of image and the noise introduction. Today, in this class, we are going to discuss about some noise models and the probability density functions of different noises, right? So, today we are going to discuss about these things. There are several types of noise models are there, and their probability density functions also we are going to discuss about. In digital images, in digital image processing, digital images are prone to a variety of types of noise. Noise is the result of errors in the image acquisition process that the result in pixel values that do not reflect the true intensities of the real scene. So, we know that already these things. Digital images are prone to variety of types of noise. Noise added to the images means the result of errors in the image acquisition process that the result in pixel values that do not reflect the true intensities of the real scene. So, depending upon the disturbance, the noise can affect the image to the different extent. So, different noise models are there. First one is Gaussian noise, second one is Rayleigh noise, Erlang noise or gamma noise, exponential noise, uniform noise, impulse noise or salt and pepper noise, and the periodic noise. We are going to discuss in detail about everything. Noise can be described in terms of spatial descriptor. Now, a spatial noise descriptor is nothing but it is a statistical behavior of Cray level values in the noise component. It can be considered as random variable. So, we are considering the noise as random variable, so that we are going for characterization of probability density function. So, in communication systems, why do we go for random variable and random process? In order to describe or in order to characterize the noise characterization, we are going for random process and random variables. So, this mathematical tool, random variables, are used to calculate the noise characterization, right? So, characterized by the probability density function. So, here you consider in order to calculate the PDF probability density function, we must know the values of mean and variance, right? So, mean is represented as E, variance is represented as sigma. So, how do we calculate mean and variance? Means if we are having a standard set of data, this is a grayscale value. Here you consider this is a grayscale value. Wait, hold 2 minutes. Consider a population consisting of following 8 values. This is a grayscale value because the grayscale value varies from 0 to 255. So, the 8 data points are we are taking average for this. So, the average value is known as mean value. So, to calculate the population of standard deviation, what you have to do, each and every value you have to subtract with 5. So, after that you will be getting square root you will be taking for this particular values, then dividing with total values, you will be getting standard deviation. This is what how do we calculate standard deviation and mean value, right? The first type of noise we are going to discuss about is Gaussian noise. So, this is about a Gaussian noise model. This is most frequently used noise model. The PDF of Gaussian noise is characterized by means of this equation. This is called a probability distribution function of Gaussian noise. This is the shape is like bell like shaped, right? So, the particular Gaussian noise is also used to characterize the electronic noise, right? So, it is also called electronic noise because it arises in amplifier or detector. So, the Gaussian noise arises due to because of amplifier are detectors. So this is an electronic noise. Gaussian noise caused by natural source such as thermal vibration of atoms and discrete nature of random of warm objects. So Gaussian noise generally disturbs the gray values in digital images. It disturbs the gray values of digital images. That is why Gaussian noise model essentially designed and characterized by its PDF or normalizes histogram with respect to gray value. So again I am repeating what is Gaussian noise model. It is also called as a electronic noise. Gaussian noise is also called as an electronic noise because it arises in amplifiers or detectors. The main sources are amplifiers or detectors. Gaussian noise caused by natural sources such as thermal vibration of atoms and discrete nature of radiation of warm objects. Gaussian noise generally disturbs the gray values in digital images. That is why Gaussian noise model essentially designed and characterized by its PDF and normalizes the histogram with respect to the gray value. So this is the equation of this is the equation of probability density function of noise. So we cannot able to recover. This curve is known as probability density function of Gaussian noise. So here the 1 by root 2 pi sigma e power already we know that we have studied in random process. This equation deals about P of Z. Z is a gray value. Here because the input is about gray value. So P of Z is equal to 1 by root 2 pi sigma e power minus Z minus mu the whole square divided by 2 sigma square. Z is a gray value, mu is the mean value of mean of average value of Z. Here we are taking mu as a mean, sigma as a standard deviation, sigma squared is a variation. This is looking like bell shaped. This is the maximum value, this is the minimum value. So 70% of value. So when Z is defined by the equation, this equation, it is about 70%. It is about 70% of its value will be in the range of this equation. This consists of 1 sigma, this consists of 1 sigma, this consists of 1 sigma, this consists of 1 sigma. The 70% will be because clearly I will show. This mu plus sigma and mu minus sigma shows that the Gaussian noise is about 70% of its value. But the 90% value will be between here there will be another 1 sigma, here there will be another 1 sigma. If this sigma 2 sigma is added means we will be getting mu plus 2 sigma and mu minus 2 sigma. So the minimum value is about 70% and maximum value is about 90%. Okay, so this is about a Gaussian noise model, right? This is the important equation that you have to study. The shape is look like bell shaped, so that it is called a Gaussian. This distribution is same as that of Gaussian distribution in PDF, so that it is called a Gaussian noise. This kind of noise is called a Gaussian noise. So next type of noise we are going to discuss about is Rayleigh noise. This is about Rayleigh noise. This Rayleigh noise deals about this is used to approximate the skewed histogram, right? This is the equation of Rayleigh noise. PDF probability distributive function, probability density function of Rayleigh noise is given by P of Z is equal to A by B. So A by B, 2 by B, Z minus A, e power minus Z minus A the whole square by B, because this is about what? This is the equation of this shape is known as, this shape is like a skewed form, skewed shape, right? So here we are having equation AB, this is Z gray value, this is P of Z, right? So the equation is about 2 by B Z minus A e power minus 2. This equation will be obtaining when Z is equal to greater than or equal to A. This equation is known as, after greater than A, greater than or equal to A, you will be getting this equation. Otherwise this will be 0. Below this the equation will be 0. So B of Z is equal to 2 by B Z minus A e power minus Z minus A the whole square divided by B. For Z is greater than or equal to A, this equation. So mu also will be getting mu, mean of average value of Z. Z is the gray level, mean of average value of Z, and sigma square is the variance. So sigma square is we are obtaining by using this formula. So the shape is like a skewed one, so it is quietly useful for approximating histograms, skewed histograms, right? So next kind of noise is about gamma noise. Gamma noise is, it is also called Erlang noise. The shape of this plot function, that is PDF function, is look like a gamma, so that it is called a gamma noise. And the P of Z is here we are writing as about for Z is greater than or equal to 0. The waveform starts here itself, right? The waveform starts here itself. So Z is greater than or equal to 0. The equation is like this. For less than 0, there is no value. So A is greater than or is 0. Here Z is a gray level, and mu is a mean of average value of Z, sigma square variance. So mu can be calculated by means of this formula, and is sigma square is also calculated by means of this formula. B is equal to A square. So positive integer A is greater than 0. The above equation is called Erlang density. If the denominator of this gamma function is gamma of B, then it is called gamma density. This is also called gamma density. This is the noise model of Erlang or gamma model. So up to this we are winding up. So next kind of model we will be discussing in next class. So thank you for your cooperation.